All right, 4.1, radian degree measure. Trigonometry. Trigonometry means measure of triangles. All right, does anybody remember what geometry means?
Measurement of shapes.
What? Not measurement of shapes, no. What does geo mean?
Earth.
Earth, exactly, okay? So geometry actually means measurement of earth. All right, so now we're on trigonometry, which means measurement of triangles. That's the tri part. Remember, when you actually measure an angle, you go from an initial side to a terminal side. Okay, an initial to a terminal. Now, we're going to mostly deal with the axes. So this is actually your initial side, and you go to a terminal side. That's how you measure an angle. You should probably write that down, but anyway. If you're going a positive angle, you go counterclockwise. Okay, a positive angle is counterclockwise. A negative angle is going clockwise. All right, remember that from Algebra 2 maybe? I hope so. If not, write it down. This is actually what we're going to be talking about a lot. If you go and you end up at the same angle a different way, those things are said to be coterminal angles. All right, that's a very important vocab word that we're going to be talking about. All right, so for instance, this alpha is our positive angle, this beta is our negative angle, and they made at the same angle, which are called coterminal angles. They just got there a different way. All right. Now, if you look at this one, alpha and beta are both positive angles. However, beta actually travels all the way around and then back up again. All right. But they actually measured at the same angle. Those, again, are said coterminal. All right. All right. I need a reader. Joe Marr, I've missed you. Go for it.
The measurement angle is determined by the amount of rotation from the initial side to the terminal side.
All right. So, again, it goes from an initial to a terminal. Now, the definition of a radian. Kayla's going to read for us.
1 radian is the measure of a central angle 0 that intercepts an arc S equal in length to the radius r of the circle.
All right. So, this is actually theta. All right. So, theta is equal to your arc length over your radius. Okay. So, theta, measured in radian mode, because that's what we're going to be working with most of our mathematics, is our arc length over our radius. Now, this is it put on the circle. Okay, you guys dealt a little bit with this last year, so hopefully a little bit of its review. 1 radian measure is said to go this much. Okay, an arc length over its radius, it's said to go that much. And then 2 radians, and then 3 radians. Then just a little bit of 3 is halfway around the circle. And then 4, 5, 6, and then do a little bit more than 6. Is a little bit more. What is halfway around the circle? What? It's pi, exactly. So this is actually pi. And then all the way around the circle is actually how much? 2 pi. And so a quarter away around the circle, it doesn't go all the way to pi. This quarter would be actually what? We don't want to say 1/2 pi. We're going to say pi over 2. Yes, it's the same thing, but we're going to call it pi over 2. So right here, if I add a little bit to it, if I get this axis would be what? 3 pi over, not 4, but 2. All right? So it goes from 0 to 2 pi, and then pi over 2, then pi, and then 3 pi over 2, and then back up to 2 pi. All right, and then over and over again. Now, before I go too much further, what about is pi? It's about 3.14, right? And then pi over 2, well, if I divide that by 2, that would end up being about what? 1.57. Those are issues, guys. Those aren't exact. All right, and then 3 pi over 2 is about what? 4.71. All right, exactly. Go. So on this one, we're going to sketch our positive angle 13 pi over 6. All right, a lot of what we're going to be talking about is what quadrant is something in. All right, and so if you can understand common denominators, you can understand these. So if I have 13 pi over 6, well, this is pi over 2, right? Right, and then this is pi and so forth and so on. Well, I want a common denominator with a 6. So how do I want to think of like pi? I want a common denominator of 6. So what do I want to think of pi as? 6 pi over 6, right? That's the same thing as pi, all right? I'm just making a common denominator. So instead of 2 pi, how could I say that one? That could be what? Not pi over 6, but 12 pi over 6. All right, so 2 pi is the same thing as saying 12 pi over 6. So it definitely goes around my entire circle at least once, right? 13 pi over 6? Well, if I already went 12 pi over 6, how much pi over 6 do I have left? I got one of them. You follow me? So I just go a little bit more. I go a little bit more, and I'm right there. So that is actually where 13 pi over 6 is. So what quadrant would 13 pi over 6 be located in? Quadrant 1. All right. Let's do it again with 3 pi over 4. So I need to figure out where 3 pi over 4 is located. So again, I start out at 0. Because it's a positive, I'm going to be going counterclockwise. How do I think of pi over 2? 2 pi over 4. All right, pi over 2 is the same thing as 2 pi over 4, right? It definitely gets to that part, right? Well, how do I think of pi? I think of it as 4 pi over 4, exactly. And so, where's 3 pi over 4? In between them. So 3 pi over 4 is right there. All right?
Yes, unit circle again.
Yes, we're going to get to the unit circle on your block day. All right, so what quadrant would that one be in? 2. It's in quadrant 2. All right, this next one, I got negative 2 pi over 3. All right, yes, I'm going to be talking about different techniques with this. But for right now, negative angles move which way? Clockwise. They move clockwise. So if I'm going backwards, first of all, if I have this as like negative pi over 2, okay? When I go backwards, they kind of flip, all right? And I was having a discussion with a student last period. Pi over 2 is usually up here, true? And 3 pi over 2 is usually down here. Well, if they're negative, they kind of flip sides. Because if you change its y value, it actually flips over the what? The x-axis. All right, so that's really what's happening when you make them negative. So that's negative pi over 2. This would end up being like negative pi. This would be negative 3 pi over 2 and so forth. That's negative 2 pi and so on. But how do I want to think of this negative 2 pi over 3 and this negative pi over 2? I need common denominators. What would be my denominator here? 6. Exactly. So instead of saying negative 2 pi over 3, I kind of want to think of it as negative 4 pi over 6. All right. And instead of thinking this is negative pi over 2, I kind of want to think of it as what? Negative 3 pi over 6. And instead of thinking this is negative pi, I kind of want to think of this as what? Negative 6 pi over 6. So if I need negative 4 pi over 6, I go a little bit, and then I need to do what? Do I need to keep going? I need to keep going a little bit more, and it'd be right there. All right? So there's where negative 4 pi over 6 is. What quadrant would that end up in? It ended up in quadrant 3. All right, I want to freestyle one. Tyler, pick a number. 4 point what? 3. 4.3? Love it. All right. So now I have a theta equals 4.3. And I need to figure out what quadrant that thing is located in. All right. So this is usually pi over 2. But now I'm dealing with these numbers. So what do I want to think of pi over 2 as? 1.57. And then pi is usually what? 3.14, right? And then 3 pi over 2 is approximately what? 4.71. So 4.3 is located in what quadrant? It's in the third quadrant. You see how that worked? All right. So 4.3 is in between 3.14 and 4.71. All right. And that will give us enough information for what we need to do with it. All right. All right, we're going to find complements and supplements of those angles. So the first one we're going to work with is 2 pi over 5. All right. A complement adds up to how much? 90. But in radian mode, I want to think of 90 as what? Pi over 2. So we're going to say pi over 2 minus 2 pi over 5, okay? Because that's what we're going to get. 2 pi over 5 plus something gives me pi over 2. That's what complements are. All right, so we're going to kind of do inverse operation. So how do I want to think of pi over 2 as? 5 pi over 10, exactly. So we're going to say 5 pi over 10 minus, how do I want to think of this 2 pi over 5? 4 pi over 10. So how much do I get? I get pi over 10. So pi over 10 is 2 pi over 5's complement. Because together, how much would they add up to? 90 degrees, or pi over 2. All right, so now let's find its supplement. All right, so its supplement adds up to what? 180 degrees. All right, you got to turn 180 degrees up. So now we're going to say pi minus 2 pi over 5. So how do I want to think of this pi, though? 5 pi over 5. So 5 pi over 5 minus 2 pi over 5 is how much? 3 pi over 5. And so 3 pi over 5 and 2 pi over 5 are supplementary. All right. Pretty good in the hood? All right. Let's keep moving. So part B is asking me to find the complement and supplement of 4 pi over 5. So its complements would add up to how much? 90 or pi over 2. So now I have pi over 2 minus 4 pi over 5. Well, how the heck do I want to think of pi over 2 as? 5 pi over 10 minus 8 pi over 10. And so what do I get? I get negative 3 pi over 10. Now, some people will say that it doesn't have a complement because what kind of angle is that? That's a negative angle. All right. So depending on what literature you look at, they might say no complement on that one because you're not going backwards. Okay. I'm not going to make you do that. So anyway, I don't. So some say no. All right. All right. This next one, I need to find its supplement of this one. So now I say pi minus 4 pi over 5. Well, how do I want to think of pi as? 5 pi over 5. So I end up with pi over 5, and that is its supplement. All right, pretty good? All right, let's keep. From degrees to radians and radians to degrees. Okay, so we're going to do a little bit of unit analysis. 180 degrees is the same thing as what? As pi. All right, it's the same thing as pi. So if I have to convert from degrees to radians, I multiply by pi radians over 180 degrees. That will cross cancel my degrees. If I have to convert from radians to degrees, if I'm converting radians to degrees, I multiply by 180 over pi. All right. So depending on what we have to what we need, we're going to multiply by 180 over pi or pi over 180. All right. Now, those things at the bottom are some things that we should just kind of know. 30 degrees is the same thing as pi over 6. 45 degrees is the same thing as pi over 4. 60 degrees is the same thing as pi over 3. All right, pi over 2, same thing as 90. Pi is 180. 360 is 2 pi. All right, so those are some known ones that we should just kind of know by heart. All right, hi there. So if I have to go from 135 degrees and I need to go to radians, okay, so I need to cancel out my degrees. So what do I need to multiply by? Pi over 180. All right, because it's really pi radians over 180 degrees. That would cancel out my degrees. So I end up having 135 over 180 pi. Well, what do 135 and 180 have in common? What could I simplify those with? Are they divisible by 30, 45, 60, 90? Yeah.
Did you say that comes out to 135 over 180 pi?
Yeah.
The pi goes down?
No. Pi is still up top. So 135 pi over 180. All All right, so they're both divisible by 45. So what would I end up having? 3 pi over 4. All right. All right, 540 degrees. So I'm going to multiply 540 by what? I'm going to radians. So pi over 180. So I'd have a 540 pi over 180. What are both of those divisible by? You can go any further. It's actually 1/8. So we could actually simplify this to what? 3 pi. So this can actually simplify all the way to 3 pi. Now, what is 3 pi coterminal with? It's the same thing as pi. Exactly. All right, so you'd go all the way around for 2 pi and then back again for 3 pi. It is the same thing as saying pi. All right, let's do negative 270. So now I end up having negative 270, and I multiply it with pi over 180. All right, this is not negative 90. What is this? Negative what? Negative 3 pi over 2. Now, what is negative 3 pi over 2 coterminal with? This is the same thing as pi over 2. Exactly. So negative 3 pi over 2 goes this way, which is the same thing as pi over 2. All right, these are coterminals with each other. All right, let's do these next ones. So now I'm going from radians to degrees. So now I'm going from negative pi over 2 radians, and now I need to make it degrees. So now what do I multiply by? 180 over pi. So my pi's cancel, and now what am I left with? Negative 90 degrees. All right. All right, this next one. I have 9 pi over 2 radians. So, what do? Multiply by what? 180 over pi. So what do we get here? We get 810 degrees. All right. Now, what is the same thing as 810 degrees? What is 810 coterminal with? 90 degrees, exactly. All right. And the way we did that is we go around once, and that's how much? 360. We go around again, so that's how much? 720. How much do I have left? 90 degrees. All right. So that's actually the same thing as saying 90 degrees. All right, this next one. We have 2 radians. All right, we have 2 radians. So now we say 2 times what? 180 over pi. Well, this would be 360 divided by pi. We don't want to leave it in that form, so we're going to put it into our handy-dandy calculator. And once I do that, what do I need to round to? 4 decimal places. So what would it round to? $114.16 degrees. All right. What quadrant is 114.5916 degrees in? It's in the second quadrant. All right. Because it's just after 90 and it's not quite to 180. All right. Pretty good. All right. Work on your radians.